Hi everybody, I have had a request about one of the questions in your waves assignment, and this is question 3b under waves interference, and this is on the back page of your waves booklet. It is this question. So I thought I'll just make a little video and explain this to you. So the question is, the diagram shows how a beam of red laser light reflected from the surface of a compact disc. So that's your diagram. There's your red laser light, and that's your compact disc. It shows how the light is reflected. And the question is, explain what the multipled and angled reflections indicate about the grooves on the reflecting surface of the CD. Now, so I have over here a compact disc. Okay, so, and if you can see, it kind of gives out all this light. And the surface of a CD is shiny, and so is the surface of a mirror. They're both shiny surfaces, but the surface of a mirror does not give you the same effect that a CD does. So there is something different about a CD, a compact disc, and the surface of a mirror. Now the difference is the surface of a mirror is flat, it's plain, and whatever light falls on it is reflected. That's what happens to the CD as well. But if you have a parallel beam of light falling on a plain mirror, the reflected beam is also parallel. They're parallel to each other. Now, as you know, CDs, DVDs, Blu-rays, all these things, they store information. And the way that they store information is that the surface of a CD is not plain or flat like the surface of a mirror. It's not flat like that. In fact, the surface of a CD, if you look at it through a magnifying glass, you will find that it is made of what they call pits and lands. So there's a whole lot of little grooves. They're in a spiral, and that is how the laser reads information. So all this information is coded in probably as 0 and 1, and that's what happens. So that's why they tell you that don't damage a CD by touching the inside of it. So you only hold the outside. You don't want scratches in your CD, because then the information is not be able to read properly. Now this question is, why do you get all this sort of rainbow colors with the CD? Now the reason is the CD almost acts like a diffraction grating. So you know, a diffraction grating has got a whole lot of little grooves. So in place of, but light actually goes through them and it bends. Now the CD, it doesn't have grooves, but it's got these little deep pits, and the raised portions are often called land. So when laser light falls on it, they're reflected off at different angles, and the gap of the pit is about the same as the size of the wavelength of the waves. Now what does that mean? Because you know, in a diffraction grating, the grooves are really small, and the size of the gap is about the same as the wavelength of the waves. And this is important because you have a whole lot of circular wave fronts emitted which interfere with each other. A similar thing happens. So when the size of the grooves is really small, reflected light gets reflected in different ways, and they kind of interfere with each other constructively and destructively, and they're reflected off different angles, and that is why you get the same sort of effect. Okay, so that is that's the answer to your question 3b. I hope that makes sense, and bye for now.